Hi everyone, my name is Courtney Brown and I'm a Senior Marketing Manager here at EDB. I'll be your host today for our webinar, Best Security Practices with PostgreSQL. I'm joined by Mark Linster and Dave Page. Before we get started, I want to go through a few housekeeping items. This presentation is being recorded. We'll be sharing the recording along with the slides after the broadcast. The lines are currently muted. If you have a question, feel free to submit it in the question panel. Today's session has been scheduled for an hour. We expect the presentation to last most of the time today, and we'll allot any extra time for Q&A. If we don't have time to address all of your questions, we will be sure to follow up with you afterwards. And now, without further ado, here are Mark and Dave.
All right, thank you, Courtney. Okay, so what we're going to do is I'll give you a very, very brief introduction to EDB. Promise it won't take more than 2-3 minutes. And then we'll start diving into aspects of data security, obviously data security for Postgres. We'll dive through some general recommendations and we'll talk about the framework that we use and what our focus will be today, because obviously, you know, security could be something that we spend days and days, if not weeks on. So today we'll have a very specific focus to make the recommendations that come out of today also actionable and make sure you actually get value out of this. Then we'll have a little section on data encryption also, and then at the end we will hopefully have enough time for Q&A. Any questions, as Molly said, as Courtney said, please put them into the chat, and you know, we'll answer as many of them as we can, and if not, we'll mail them around afterwards. Okay. So, you know, EDB, who is EnterpriseDB, or EDB as we're more commonly known? Well, we've been around since 2004, always involved on Postgres and involved with really nothing else but Postgres. Some of our team members have been involved with Postgres for even longer than that, like Bruce Momjen, for example, and I think Dave has also been, well, probably about as long as the timeline of EDB goes, been involved in Postgres. We have been contributors to Postgres, but also to Postgres Advanced Server, which is our own Oracle compatible distribution of Postgres. Today, we'll talk more about generic things, and we'll call out whenever there is something where EDB Postgres Advanced Server has an additional feature that might be of interest to you. So over the years, we've contributed to Postgres things like the heap-only tuples. I think that was very early in release 8. Materialized views, parallel query. That infrastructure was built by Robert Haas. The just-in-time compilation work that was done by Andres Freund. Serializable parallel query was built on the parallel query engine a little bit later. So we're very active and continuously involved in making Postgres better. At the same time, you know, we've had significant commercial success. Today, we've had over 4,000 global customers. Gartner has had us in the Magic Quadrant for relational databases for 7 years in a row. And what we're especially proud of is we're the only open source based relational database that is still left in the Magic Quadrant. So that's something that we're particularly happy about. But then, as I said, we're very involved in the open source community. On that side, just to call out a few of the names that you may know if you work with Postgres, you've come across their postings in the hackers list and on the community. You've probably seen them speak at events. Let me start from the top here. Bruce and Dave have been with the Postgres core team for quite a while. I'm really happy to have both of them on our team. Bruce been the co-founder of the Postgres community, and they've been a long-term member of the Postgres core team. We have a number of major contributors. So if you go to the Postgres website, you'll see Amit, Devram, Robert mentioned as major contributors. And by the way, Bruce and Robert are also committers, so they can actually change the code in Postgres. And then there's a number of contributors. They're also named on the Postgres website, and they're regularly, contributing patches and new software to Postgres and also to pgadmin, where Dave is the key driver of that project, and people like Akshay Joshi and Ashesh Vashi are working very closely with him to make PG Admin also move forward. Okay, that's enough about EnterpriseDB. If you have any further questions, you can ask afterwards. I'm glad to dive into it. So security has lots of different aspects, right? I mean, there's a lot of different teams that are involved in data security. Today, we will not talk about all of these things. I mean, some of these aspects, for example, touch on GDPR compliance. We've done a presentation about that a while ago. But today's focus is going to be entirely on data breaches and unauthorized access. So we're looking at those aspects and including things like unintentional data corruption, but mostly our focus is going to be on unauthorized access, data breaches, and then how do you deal with notification and compliance. The other aspects, such as unintentional corruption, are things that are covered, for example, under GDPR, and where you need high availability, you need to be protected from hardware failure, network failure, you need to have a disaster recovery plan. Operator error is probably the most frequent threat to data security, because we all know the famous DBA oops moment where that was the wrong command, that shouldn't have been run right now, and oh God, what do we do now, right? I mean, I've personally done it, so it happens, and those are things that you need to be protected from. And then very important is also the loss and management of encryption keys. But as I said, today we'll focus on the aspects of data breaches and unauthorized access. Okay, I'm going to turn it over to Dave here for general recommendations.
Thank you, Mark. Morning, afternoon, everybody. So general recommendations here are kind of the high-level things that really should apply to everyone. We'll look at some more specific details later on, but those tend to be a bit more specific to individual deployments in terms of whether or not a particular thing is relevant, or whether an example we'll give later, for example, is in the language that you're using and so on. But at this high level, these recommendations really should apply to everyone. First and foremost, please absolutely keep your operating system and your database server patched. We work with Postgres very much like vendors such as Red Hat do, or Ubuntu with their long-term support releases. We release updates regularly that fix bugs, including security bugs and data corruption bugs. But we release those in what we would term as a minor release. So 12.1 to 12.2 is a minor release change. We work extremely hard to make sure that there are no behavioral changes in Postgres beyond the fixing of the bug between those two releases, to make it as safe as possible for you to update. We will always say that it's safer to update the database software than not to update. But unfortunately, we do see a lot of users that don't do that. And 5 years down the line, they find themselves running a release that is very out of date and has known issues in it. Secondly, don't put your...
And I think, Dave, we also need to remind the audience here that you have to hold your cloud provider accountable to making sure that they do apply these minor updates, right? Do not allow your cloud provider to give you a Postgres that is not correctly patched. If you have a cloud provider where their patching level is month behind, and there are outstanding CVEs that they have not addressed, do not allow them to do that. And it happens more frequently than you think. Sorry, Dave.
Absolutely, no problem. So second of all, don't put your database directly on the internet. It sounds obvious, but again, it's surprising how many people actually do this. If you're using cloud services, for example, use a virtual private cloud, have your database tucked away in a subnet where it can't be directly accessed from random hosts on the internet. If you absolutely must put it on the internet, And for me, that would require some really incredibly strong justification. Use the firewalls that are available to you, whether they're hardware devices or cloud vendor provided devices, and lock down that port so that it's only accessible to the hosts that actually need to be able to get to it. Isolate the database port from other network traffic. So yeah, as I say, firewall it. If it's there, even if you are inside a private network, then lock down the port to only allow connections from the systems required. Now, one of the key points, and we'll touch on this further throughout, is the principle of least privilege. Grant users the minimum access required to do their work and nothing more. This is a very general principle, but it applies in so many different places. Basically, work on the theory that you lock everything down so nobody can do anything, and then add permissions bit by bit until you get to the point where everything works, and then do not add any more permissions or any more access.
I mean, really go into all your users, take all their privileges away, and then only give them what they need. Don't assume, don't start with giving them everything and then taking stuff away. Give them nothing and then add. It's really, this is the most important recommendation.
Exactly. Next, restrict access to configuration files. Configuration files will allow you to change the way that Postgres can be accessed, of course. So the pghpa.conf will allow you to do things like accept connections from different hosts on the network. It would allow you to change the authentication mechanisms from, say, Kerberos to trust, allowing people to log in without any authentication whatsoever, just trusting that they are who they say they are. So it's absolutely crucial that you do not allow people to modify those files unless they absolutely need to be able to do that to do their jobs. Tied in with that, just as a general rule, don't let people log into the host that is running the database server. Unless they absolutely have to. In particular, and related to that, is don't allow the database super users to log into the database server itself remotely. Restrict where those people with the ultimate power can log in from as tightly as possible. We'll talk some more about auditing later on, but ensure that each user has their own login. Don't share passwords, ever. This is also important because it allows us to track who does what to some degree. We can configure auditing on the server and know who is taking what actions on the server. So even if we don't prevent them breaking something, well, at least we can see who did it and when. Integrate the security in your in the database system with your application if you can. Don't rely on the application itself providing all the security for you. We have some software that I've worked on in the past where we do exactly that. We have code in the front end that prevents access from unauthorized users or provides role-based access controls to different functionality. But that works hand in hand with things like row-level security on the back end to ensure that users absolutely cannot get to data or features or functionality that they shouldn't have access to. Finally, keep backups. Backups are absolutely critical. And if you don't test your backups and have a tested recovery plan, you do not have backups. It is surprisingly common to come across situations where people thought they were taking regular backups, but they never actually tested them. And then when the server spits out 2 disks at once and you lose a RAID array, they come to restore it later on and find that actually there was a problem with their backup software. They'd missed the directory, or they backed up the wrong directory, or I don't know, back in back in days gone by, we might have been using tapes and the tape had worn out, but we didn't realize it. So make sure you regularly test your backups and have a plan in place to restore from those backups, so you know exactly what you're doing. The moment disaster hits, you can grab the backups, get everything up and running again as quickly as possible.
Yes, and I think, you know, as we always say, backup is not the problem, recovery is the problem, right? So, and it's not just testing, it's actually knowing how long it takes. Okay, so let me just go through multiple layers of security here. Security, as we've already said here, is not just one place. There's not just one area where you go to secure everything. It really looks at, okay, securing the database. Well, you need to do the access control to the tables, to all the objects, and we'll talk about that at more length. You need to think about encryption. You need to think about protecting the files, because again, if somebody can get to the files, well, they'll figure out how to get at what's inside the files, right? If you can encrypt data, so you can do column-based encryptions, or you can do data file encryption. In both situations, you need to think carefully about, you know, how you manage the encryption key, because again, if somebody gets to the key, all the encryption has been for naught. Then, you know, access to the database server, as Dave said at length, that's often something that is forgotten. Then the network access, the authentication, things like data redaction, auditing, or SQL injection prevention. I mean, all those are part of security, right? So you got to look at this, including access to the database host, access to the data center, right? Because if somebody can get physically to the database, to the server, well, you know, again, they're almost there at that point in time. And then encryption in transit. And you have to think about this like a bank, right? In a bank, the doors are locked. There is a camera. There is an additional door to the vault. There's a camera in front of the vault, and there's a huge big door at the vault. And then again, the deposit boxes inside the vault are again secured. So just like a bank has multiple levels of protection for whatever you lock away in their safe, this is the same thing. You really, really have to understand how to protect all of these aspects and spend time on understanding the different threat vectors that you have to be concerned about, right? Are you concerned about somebody stealing the disks? Are you concerned about the DBA getting to the data? Are you concerned about super users getting to the data? Are you concerned about somebody breaking into the app and that way getting at the data? You have to understand these things to then use the right security mechanisms, okay? So today, we'll talk about the access to the database application, to the data within the database, and the security, and how to secure the data, so encrypt the data that's inside the database, right? All the other aspects like data center security, etc., we're not going to touch on today. So the model that we'll use to talk about security and how to organize all of these aspects is the AAA model. It's something that is fairly popular for security architectures, especially for network security architectures, where we're distinguishing between authentication, authorization, and auditing. And we'll extend that a little bit with encryption. And authentication is really, we need to know who the user is or who they claim to be. Authorization, once we know who they are, what are they allowed to do? And then auditing is, as Dave said, just in case, keep track of who did what, but also who looked at what, right? Because in many situations, you need to find out, did somebody actually, by chance, by whatever, happen to bypass my authentication and authorization and get a view at the data that they shouldn't be able to view? Because again, under GDPR, right, you only have very, very little time to notify authorities and users of the fact that somebody, that you had a data breach. So auditing is extremely important. Authentication, authorization are the defenses auditing is how you find out whether something bad happened. And again, under GDPR, you as the database operator, you have to know, and you have very little time to report. So let's go into authentication here, Dave.
Yeah, so authentication. The idea with an authentication is proving who the user is. We don't look at what they do yet, that comes, or what they can do yet, that comes under authorization, which we'll talk about later. But authentication is really about proving that the person is who they say they are, or the system is what it says it is, because more and more these days, it's not necessarily users logging directly in, but it might be other systems, application servers, microservices, containers, whatever. Most of the authentication options in Postgres are configured in the pg_hba.conf file, which you'll typically find in the data directory on your server. If you're using Debian or Ubuntu, it's under /etc/PostgreSQL or EDB AS, whatever version. There are a number of different options that you can set here, and the hba.conf file is read sequentially when a connection comes in. So what it's going to do is match the incoming connection method and database name and username against the first line that it can, and then it will use the authentication mechanism that is specified on that line. And there are various different ones that we can use here. First of all, we've got Kerberos GSS API. So GSS API is the General Security Service API, which typically is what's used with Kerberos. And this allows us to offer single sign-on to Postgres in Kerberos environments. One thing to be careful of here is that by default with Kerberos, data is still sent over the connection unencrypted. So make sure you also enable SSL, or in recent versions of Postgres, GSS encryption. Very similar to GSS API, but on the Windows side is SSPI. That allows you to use Windows single sign-on authentication. You can do that quite trivially just on a single standalone machine if you've got the client and the database server on the same machine. If you're running on separate machines, then you'll need to be running in a domain for SSPI to work across using domain accounts. Again, very, very simple to set up. Check the Postgres documentation and you should be able to follow that pretty easily. We do have, we know a lot of users are using LDAP for authentication. As a general rule, you should try not to use LDAP unless Kerberos is out of the question, or SSPI. The reason for that is that LDAP passwords are forwarded to the LDAP server by the database. With Kerberos or an SSPI system, Postgres never actually sees the user passwords at all. So it's arguably more secure than LDAP, where your password will get sent to the database server and then will get forwarded to the LDAP server. Radius is another option. We do not recommend using Radius at all, primarily because it has weak encryption. Just avoid it. Certificate authentication is very useful, primarily when you're building systems that need to talk to each other. So when you've got an application server that needs to talk to a Postgres instance, we'll typically recommend that set up using certificate-based authentication. So you'll generate from a certificate authority that you might have within your organization a server certificate that is used on Postgres for both encryption and authentication. And then you can generate client certificates that are used to authenticate clients to the server. The Postgres server can validate full chain of trust, and you have various options for how trusted different configurations are. So for example, you could say that you don't actually care about doing full validation of the chain of trust. You just validate that the server can recognize the client certificate. Finally, for end users, where you can't use Kerberos or other similar mechanisms, we have MD5 and Scram passwords. This is the most basic setup, where the user has just requested a password by the database server. The database server is responsible for storing those passwords in a hashed form, and it's sort of completely standalone authentication mechanism that you can use. MD5 has been the default for many, many years with Postgres. However, in the last 3 or 4 releases, we've been moving to Scram. I think pretty much all the major drivers now fully support Scram. Scram is preferred over MD5 just because it's far stronger hashing and offers various security advantages. You can also use EDB Postgres password profiles with the password authentication mechanisms in Postgres, which can allow you to do some of the things that typically you deal with in your LDAP or in your Kerberos environment, such as password strength and complexity and so on. So Mark, do you want to talk about password profiles?
Yeah, before we dive into that, I think we have a quick poll that we wanted to run here, just to get an understanding for, what our users use today. So if you wouldn't mind, quickly entering here, we'll only want to run this a short time because we're already far into our hour here. And so Courtney, you can see how people are filling in. And I think if we're at 70, 80%, we should probably close the poll, give people a couple more seconds.
Yeah, we're right about 50%, so we'll give them a little bit more time.
Okay.
Okay. And the poll, and here we can share the results.
All right, good. That's not unexpected. Dave, if you want to comment on this a little bit.
Yeah. So yeah, MD5 password is the clear winner. I'd strongly suggest everybody who's using MD5 investigate moving to Scram. Otherwise, interesting mix. Trust, I really hope, is only being used on personal developer machines where you really don't care about the data, and not in any production systems. But yeah, otherwise that's roughly in line with what I'd have guessed, I think.
Yeah. Yeah, for me, I thought the SSL certificate was not going to be this high, 32% using certificates for authentication. That's really good because it's a very secure and durable and very well manageable way for machine-to-machine communication. Okay, thank you. Thanks. All right, so as I said, we're running a little bit behind here. So I'll try to find the right balance between the content and not running over. Password profiles is something that we have developed to support PCI compliance. So basically, password profiles works exactly like the Oracle password profiles. So you can specify the number of the complexity of the password, the failed attempts, the duration of a lock-in, etc. So it gives you additional capabilities that standard Postgres doesn't have, and that's why we added it into EDB Postgres Advanced Server. If I take a wee bit of a look into that, it's very easy to use. You just create a profile, then you add a user to that profile, and then basically inside that profile, you can say, hey, how many false login attempts and what's the password lockout time. Here it's, I think it's days in this case. It'll show later on in seconds in here. So now you can start managing that. And when somebody then tries to log in and it fails, well, you can see in the profile information that they had, a certain number of failed login attempts, and eventually, if they keep on doing this, then they will be locked out based on a time-based lockout, and how long will this lockout last? And then a super user can obviously go in and unlock the account again. Okay, so it's a simple and robust mechanism to allow you to manage password complexity, password rules, password reuse, etc. inside the database. But as Dave said, if you have LDAP or Kerberos, then usually that's the place where you would do that, so you can do it at an enterprise level, not just at the database level. But as we saw before in the poll, local management of the passwords through MD5 or Scram had a very high percentage. So for those users, as Dave said, if you're on MD5, consider going to Scram. And if you manage your passwords locally, consider using password profiles, because it does protect you a lot better from somebody trying to break in. And you can set, as I said, password complexity. Okay, so Dave, you want to talk about authorization?
Yeah, so now we've authenticated you as a user. We know who you are, but what are you actually allowed to do? So Postgres has two DDL commands, grant and revoke, which allow you to grant privileges to different types of objects in the database, or revoke privileges from individual users. So, for example, you can grant select access to a table to a user, but without also granting them update or insert, then there's no way that they can update existing data or insert new data. Different types of objects will have different privileges, as you can imagine. So tables will have privileges that allow you to select from and delete from and insert, update, whilst objects such as stored procedures and functions will have privileges that determine whether or not you can execute those functions. As a general best practice, revoke create privileges from all users and grant them back only to the trusted users. Comes back to the principle of least privilege that we spoke about earlier. Only allow people to do what is required to allow them to complete their work. Don't allow the use of functions or triggers written in untrusted procedural languages. So one of the really cool things about Postgres is that it's very extendable. And there's actually a lot of different procedural languages around you. We tend to support generally Python, Perl, Tcl, and the built-in PLPG SQL. But there are other procedural languages, even PLSH, which allows you to write procedural code in shell script. But some of those are what we call untrusted procedural languages. That is, they're not sandboxed. They might be able to access or run arbitrary commands in the underlying operating system. So when you choose a procedural language, make sure that you're fully aware of whether or not it is a trusted or an untrusted language, or if there is, as there is the case for some of them, both variants, and make sure you use the trusted procedural languages as much as possible. Really carefully consider whether you should ever use an untrusted one. Security definer functions can be very, very useful. So these are functions that when they're executed, the security privileges of the definer of the function, i.e. the person that created it or owns it, is taken into account rather than the privileges of the person who's executing it. What that means is that you can have a user who is not allowed to insert a row into a particular table, but they might be allowed to execute a function that was created by somebody who can insert a row into a table. So what that means, where you can use that, for example, is if you have an audit log within your database that you want to insert rows into when people perform certain actions, but you don't want the people to be able to insert their own rows directly, you could have a security definer function that is called from a trigger, for example, that allows that insert to happen even though the user doesn't have privileges to directly insert. This is kind of similar to the Unix concept of the setuid bit that allows you to run a script with the privileges of the owner of the script rather than your own privileges. Finally, I would say make sure that database objects are owned by a secure role. If you look at a Unix system, you'll typically find that system commands and system files tend to be owned by a high privileged user like root or wheels. The reason for that is if somebody manages to attack the system and gets in via a low privileged user account, I don't know, because a user has leaked their password, for example, that attacker still is unable to modify the system. They're restricted to only what that user whose password they've obtained could do. And the same basic principles apply to the database objects. If somebody does get in, we want to minimize what damage they can do to the system. So by making sure that our objects are owned by a secure role and that general users can't modify those objects, even if somebody is socially engineered into giving away their password, for example, the attacker is unable to drop tables or take other actions that might cause more damage than otherwise would be possible. Now, one thing I would add here is if you're logging statements using the log statement DDL in your configuration, the auto roll command can expose passwords in the logs. EDB Postgres Advanced Server 11 has the redact password command to prevent that from happening. So just be aware of that if users are changing their passwords themselves through a user interface such as pgadmin or an application that is using per user roles in the database server. Next slide, Mark.
Okay.
Now, row-level security is something that should also be considered, often known as virtual private database. What row-level security allows us to do is, instead of just restricting access to particular tables, we can start to restrict on a per-user basis what subset of rows a user can access within those tables. So in the example here, we're creating a table called accounts. We're enabling row-level security on it. And then we're creating a policy that basically says, only allow access if the manager's name is the same as the current user's name. So this basically restricts managers for seeing records related to people other than themselves. So the account, different account, one manager could not see the account records that are associated with a different manager. Related to that, in EDB Postgres Advanced Server, we also have the DBMS RLS package. That allows you to use Oracle-style virtual private database using the same underlying mechanisms as we have in Postgres. Next slide, please, Mark.
Yep. So data redaction is another capability here, and data redaction basically means that you can, just like in the row-level security, you can define a profile where you can define groups of users, roles in Postgres, and say, well, there is visibility policies associated with those roles, and you can do something like what I'm showing here right now, where you know, I have a privileged user And when that privileged user selects from a table called employees, they get to see everything, including the social security number, which usually would be, highly protected, personally identifiable information. But if a standard user, for example, in this case, somebody belonging to a role that we called redacted user, accesses the same table and runs the same query, then they would get a redacted version of the social security number. So again, that's a capability built into EDB Postgres Advanced Server that allows you to define, to use the roles in Postgres and to define policies that allow you to mask certain data elements when certain user groups access them. So again, that's another way to allow people to use their system, run the same queries, but not get access to all the same data. Okay. Dave already mentioned, some of the auditing capabilities as the last, the last of the 3 A's. And in EDB Postgres Advanced Server, we have also enhanced the auditing capabilities, mostly because we work a lot with, banks, financial institutions, but also government organizations that need to be able to separate the log, the system log from the audit log so that they can properly track and understand database activities, who did what, but also who read which data element, right? And then we've added something called session tag auditing. The reason we do that is sometimes applications access the database through common roles, right? Where there might be only 2 or 3 different ways the application can access the database. Maybe it logs in as a read-only user, as a manager, and a super user. But it can send session tag information to say, oh yeah, this read-only user was Dave Page. To the database, only the read-only user got authenticated, but the session knows that, yeah, the person is really Dave Page. In that case, we can also use that information to enhance whatever we're auditing. Well, that allows us to do things like, write an audit log into a separate place. And, most of these commands, there's not a lot of secrets how they work. But then we can also say, okay, what would we like to to audit? For example, here we're saying that we want to audit all connections to the database, not just the failed connections, for example, but all of them. And then in the audit statement, we're saying here, hey, I want to keep track of anybody who creates a view, anybody who creates a materialized view, anybody who creates a sequence, and any grant operations, right? So this is how we can combine types of objects and types of commands, okay? And then as Dave said before, if you do this and if you start auditing or logging DML commands, remember that alter password or alter user set password is really a DML command. And if you audit DML commands, well, then the DML command will appear in the audit log unless you use this feature from EDB Postgres Advanced Server to redact the password. In that case, the password will be just X'd out. Okay, just briefly about encryption. So we talked about encryption as something that happens in multiple different places. When we looked at the multiple layer architecture, you saw that we need to encrypt data on the wire, obviously between the client and the database. We can encrypt specific columns, and we can, manage the encryption key separately using PG crypto, or we can manage it in the application. We can use LUKS-based encryption for data partitions. We can encrypt, as I said, password on the network, data on the network. We can use SSL host authentication, which will do a similar thing. And we can encrypt, the data when it comes from the client. But really important is that you really should consider encryption and understand the threat vectors that it protects you from. For example, you want to encrypt data on the disk because somebody might steal the disk, right? And that's the kind of threat that you want to be protected from. Now, just the basic Postgres tools and the operating system tools are not always sufficient. So we work with Vormetric, and we have a partnership with Vormetric for Vormetric Transparent Data Encryption, VTE, to help you in situations where the Postgres tools themselves or the operating system tools such as Lux encryption is not sufficient. So in that case, to achieve PCI compliance, depending on what exactly your auditor is concerned about, you may want to revert to something like Vormetric's Transparent Data Encryption. The link in the post here will be shared as part of the presentation, so you can take a look at the presentation that we did together with Vormetric about this topic. Okay, Dave, let's go back to talk about SQL injection prevention.
Yeah, so SQL injection is probably about the most famous way, or the most well-known way of attacking a database system. And I'm sure that probably a very large percentage of people on this webinar have seen the cartoon that we've included there from XKCD. Very, very funny for DBAs. And little Bobby tables, which are a fairly well-known name in the industry. SQL injection attacks are possible basically where applications take input from the user that is then built into an SQL query that is executed on the database server, where that input from the user is not sanitized to make sure it's safe. This almost always happens because people are creating SQL queries by concatenating strings together, where parts of those strings come from the user. That's not the only way it can happen, but it's almost certainly the most common way. If you move to the next slide, please, Mark. So here's an example. If you've got a website which is going to log in a user using a query constructed as follows. So this is largely pseudocode. So we're just basically going to say we're going to count the number of users from the users table, where the name is equal to the username that the user has input, and the password is equal to the password the user has input. We're just concatenating those strings together. So for example, we're opening the single quotes, closing the wider string, and then adding in the username, and then adding the quotes on and so on, adding the and password clause, and then adding in the user's password. So if the user enters their username as Dave and the password as secret, close single quote, or 1=1, essentially, what will actually happen with that code is you'll end up with a query like this. It says select count star from users where name equals Dave and password equals secret, or 1=1. Now, because of operator precedence and so on, the or 1=1 clause will take priority, and basically what that'll do is return the count of users in the system rather than just a 1 or a 0 as we might have expected. So if you were looking for that 0 or 1 value to authenticate a user, or more specifically, if you're looking for a 0 to say that that user is not valid, then the attacker will be able to gain entrance into the system regardless of whether they've got their username and password correct, because it's always going to return the number of rows and not 0. That's a semi-contrived example that I came up with a few days ago, but there are many, many more ways that this can happen. Websites where, for example, you call view.php and pass it a parameter that is a page name, and the page is then looked up, page name's looked up in the database, for example. You can do much more serious things than just or 1=1 to try and authenticate your way into the system. You could, for example, modify that SQL if you figured out how to put the right characters on the end to include the drop table users, which is another example of why your user that's connecting to the database to when you're running your application should not be the user that owns the table. With that example, the user might be able to modify an attempt to run the SQL that's going to drop the user's table, but at least you know it wouldn't work. But ideally, of course, you really don't want people being able to run that drop table users command in the first place. So how do we work around this? Don't use string concatenation to include user-supplied input in queries. That's really the big rule here. You do everything possible to make sure you never, ever concatenate strings and use user-supplied input when you're doing that concatenation. Use parameterized queries instead. You'll find that pretty much every driver out there, certainly every one that I've ever come across, supports user parameterized queries. Some of them do it in different ways. The language might handle it, the driver, the database, whatever. But don't try and do it yourself, because sooner or later, no matter how careful you are, you will mess it up. Very simple Python example here. This is using the PsychoPG2 driver. And what you can see is we've not put any quotes around the username and password values. We've just simply put in a %s to indicate that we're expecting a string value there. And then we're passing the values from the user into that, as a tuple, into that cursor.execute function as the second parameter after the query itself. And the driver itself will substitute in username and password into that query, quoting it, escaping any quotes that happen to be in those values, and generally making them safe as it needs to ensure that there is no way of injecting additional SQL into that query.
Okay. So then in EDB Advanced Server, we've added an additional capability where you can use database functionality. It's called SQL Protect to help you do that. So basically, in that case, instead of as a DBA, you rely on the best practices from the developer, as Dave just outlined, which is definitely, you got to hammer that into the developers that that's what they should be doing. But in case you don't trust them, there is a module in EDB Postgres Advanced Server called SQL Protect that helps you avoid any of these issues. For example, SQL Protect will not allow users to run utility commands such as a drop table or tautologies like what they've just described, MPDML, DML, where somehow somebody has removed the filter command, etc. And then you can also, as a DBA, if you don't have visibility into the app, you can tell SQL Protect to provide you a report of all the relations, meaning all the tables that have been accessed, and then you can flag those in the learning period as, yep, the website's allowed to access this table, this table, this table. Oh yeah, but not that table, right? So there's a way to help you if you're a DBA and you don't have visibility into the application to just make sure you have this additional barrier. But definitely the practices that Dave outlined are the best practices. Make sure that, that behavior stops right away during the application development, that in there we use parameterized queries, and we don't have to worry about this, about building this defense into the database. But in case you need it, it's available. Okay, we're at the end of our slides. We got 5 minutes left. I know we have quite a few questions actually. Molly, you want to take us through a few questions for the next couple of minutes?
Yes, sure. So we had a few questions that were actually submitted before the session, which was great. One of them was the the difference in features and options for ePass and community, but I think Mark and Dave did a good job doing that throughout the presentation. So let's move on to the next one. If PGA_HBA comp is not locked down as tightly as I ideally would be, how difficult would it be to hack into a default configuration of Postgres from internal subnets?
Excuse me, that really depends on where you got your Postgres from, because different versions of Postgres and different distributions of Postgres will come with different default settings in that file. Any of the ones that you get from EDB at the bare minimum will have super user passwords set during installation. In fact, on the Unix platforms, we'll limit connections to only the local host anyway by default. We don't do that on Windows because only recently has Windows been able to support Unix domain sockets. So actually, I say that. It's been a long time since I've looked at this, but I think we do actually restrict it to localhost, but on TCP/IP rather than Unix domain socket. So in answer to the question, pretty difficult unless you can also modify PostgreSQL.conf to change some of those settings. But that doesn't mean it's not possible.
Mm-hmm. Yeah, but if somebody gets to hba.conf, they're almost there, right? And I think, Dave, what you're saying is PostgreSQL.conf also gives you an additional line of defense, but both of those have to be, both of those have to be protected, because if you can get to both, and usually they're co-located, you're home.
Yeah, absolutely. And I did notice one of the other questions in the Q&A panel is, how do you protect those? Do you hide them and unhide them? No, typically we wouldn't hide them and unhide them. Make sure that only high privileged users own them. I mean, the database server obviously needs to be able to read them, so the Postgres or EnterpriseDB user needs to be able to read those files. But they can be owned by root, for example, so only the root user can edit them, or somebody who can get root privileges through an acceptable mechanism. What you don't want to do is make them group or world writable.
Okay, it looks like we have time for maybe just one more quick one. Let's see. Is it true that security definer functions are unable to perform a commit?
Functions in general in Postgres cannot control transactions, but stored procedures can. So whether or not their security definer doesn't have any bearing on that.
Okay. Now, I know we're right up on our time and we had a lot more questions come through, so I apologize for any that we weren't unable to get to today, but we'll review them afterwards and follow up with our answers. Just wanted to say thank you for joining us for this webinar. A reminder, we'll be sharing the recording along with the slides with you as soon as possible, and we hope that you have a great rest of the day. Thank you.